Hi students, in this video we're going to continue with the multiplication of rational expressions. We are going to take up more examples. Please see and watch carefully because these examples are pretty much aligned with the assignment you will be doing later. So now just quickly something about the video, the quadratic trinomial we factored in the last video. So we use the X method. A is equal to 1, B is equal to -1, and C is equal to -6. So we wrote our AC equals -6, B equals -1, and we used a factor tree. So ignoring the sign of AC, just write down the AC here and 1, 6, 2, 3, and so on. And we try to find out the two numbers when multiplied will give you -6 and when added will give you a -1. So now if you are for some question the numbers are bigger or more complicated, or you are like struggling with the signs, what sign to put where. So there is I'm going to show you some calculator steps for getting these two numbers, which will help you split up the middle term, and so you can do the factoring of the quadratic trinomial. Let's see. First step is to put y1 equals AC divided by x. So you go to y1 and put it AC equal to AC divided by x. So your AC is equal to -6 here divided by x. And for y2, you will put it equal to y1 plus x. To be able to type in y1, you go to vars, y vars, and then press enter and enter. So you have your y1 is -6 divided by x, and then you go to your y2 and you have to write it as y1 plus x. How do you get your y1? You go to vars, you go to y vars, and then press enter, and you'll have your y1 there automatically. So now plus x, right? Then you go to the table. How do you go to the table? Second graph, you'll go to second graph and you will see the table. And what do you have to do in the table? You, in the third column, you have to look for B. Your B in this case is equal to -1. So -1, you can see that here in the third column, you have B is equal to -1, and look at the two numbers that are making that 2 plus -3 make a -1, and you can also see that 2 times -3 make the AC, which is -6. So you have your two numbers now, 2 and -3. So 2 and -3. How did you get those two numbers? Your B, you look for B in the third column, which was -1, and then you get your numbers 2 and -3, and thus you can split your quadratic trinomial into -3x plus 2x minus 6, and now you can split it and do the factors like we did before. Okay, moving on. Another thing that I wanted to discuss before we actually take up the examples is how do you, just brushing up, how do you factor a quadratic binomial which has a negative sign in between the two terms? Just check, is my second term a perfect square? If it is a perfect square, write it as a perfect square, and you can use the difference of squares formula. So x square minus a square is x minus a times x plus a. In our case, a is 2 because 4 is a perfect square of 2. So you can write your the two factors as x minus 2 times x plus 2. Well, you can do this question by the x method also. In that case, you will have to rewrite it x square plus the middle term is missing, 0x minus 4, and you can have the x, and AC is -4 and B is 0. You can find the two numbers and you can do the whole process and get that same answer. But this is a faster method. If you see a difference between two squares, you can use the difference between the squares formula. Okay, let's take up Now, more examples on multiplication of rational expressions. So these are the two rational expressions we are multiplying. So there are numbers involved here. So you can multiply 24 with 15 and get a get a 360, and you can multiply the two numbers in the denominator 25 with 8 and you can get your 200, and you can find a common factor. You can use your calculator, the GCD method, and you can see that the common factor is 40. So you can divide it by 40, divide it by 40, and to see what is the other factor in each case, and you will see that this turns out to be a 9 by 5, or or you can just try to cancel out, make those numbers smaller. So let's just see how we can make our life a little easier with numbers. So let's copy down all the numbers. 24 by 25, and here I can extend this, times 15. So multiplication is commutative. If I have just the factors, I can just bring them back and forth, and then I have what do I have left? I have the variables left. Copy them down carefully, each power and each variable. Don't leave anything. Y to the power 5, and you are left with 8x squared. Okay, look at the numbers now first. If you can recognize 8 goes into, or you can see your multiplication table also, does anything go into anything here? 8 goes into 24. 8 goes into 24 3 times. So you have your 3 here. Now you can multiply. So you have smaller numbers to deal with here. You can multiply your 3 and 15 and you will get a 45, and divided by, in the denominator you have 25. Now, if you look at your multiplication chart, 20 by 20 chart, under 5 you will see both 25 and 45. 25 will be in the 5th row and 45 will be in the 9th row. So you will see that 45 and 25 can be written as, I can write 45 as 9 times 5, and I can write 25 as 5 times 5. Okay, now the numbers are taken care of. I will now take care of the exponents using the exponent rule. Y to the power 5 and x squared. Okay, so I can cancel out this 5 and 5. I'm left with 9 by 5 like I got before. And using the exponent rules now, I have a 9 by 5 x to the power. This is a 3, and then there is a 2 in the denominator, so 3 minus 2. And then I have a y to the power. This is a 2 and this is a 5. So y to the power 2 minus 5. Okay, simplifying this further, 9 by 5 x, 3 minus 2 becomes a 1, so I don't have to write that 1, and y to the power 2 minus 5 is a negative 3. Oh guys, I forgot something. What we were doing in the last video, before we were cancelling out stuff and writing the final answer, we were putting the restrictions. So we have to do that before. So I am going to put the restrictions before I started actually dividing and cancelling. So here I have a y in the denominator and I have an x in the denominator. So y cannot be equal to 0 because it will make the denominator 0, and x cannot be equal to 0. So these are my two restrictions here. So coming back, I have y to the power, and I cannot have a negative exponent, so I'm going to simplify it further and write my final answer as 9 divided by 5 x in the numerator divided by y cube, and I can just combine this whole thing. And this is my final answer along with the restrictions. Okay. Moving on to the Next question. Now I have again two rational expressions. So I'm going to write down and each numerator and denominator, I'm going to write it down here, and I will factor these. Write each numerator and denominator as a product of its factors if it is factorable. So here you can see there is no variable here, but x 5 goes into 15. So I'm going to take that 5 out and write the rest x plus 5. This is a 3. This is a 3. Because 5x and then 5 times 3 is 15. Similarly, I can take a 4 out here, x plus 2. Here, I can take 2 out, but look at this. Both these terms also have the variable. Which one has a lower power? X to the power 1. So I will take 2x out, and this will become inside. I need to make a 2x square, so it becomes a x inside. 2 and x times x is an x square, plus I need to make a 4x now. 2x times 2 makes a 4x. So I have the two factors now. The last one, I have 3 that goes into 9, so I can take that 3 out, but also both the terms have variables. This one, x square, is a lower has a lower power than x cube, so I take the lower exponent out, x square, and now I try to make 3x cube. So 3x square, one more x is required to make an x cube, plus I need to make a 9x square. 3x square is already out. If I multiply it with another 3, it's going to make a 9x square. Now let's rewrite our rational expression in form of the products of factors. Okay, so first one, 5x plus 15, I write it as 5 times x plus 3. Okay, the denominator, 4x plus 8, goes as 4 times x plus 2. Then you have the numerator of the next rational expression, and we factor it as 2x times x plus 2. And then the denominator, 3x square times x plus 3. Okay, restrictions first. So before we cancel out things, x cannot be equal to -2 because -2 plus 2 make a 0. X cannot be equal to 0 and x cannot be equal to -3. You can put x plus 2 equal to 0, solve for x and find this, that x cannot be equal to -2. So our three restrictions are x cannot be equal to -2, x cannot be equal to 0, and x cannot be equal to -3. Okay, now is the time to cancel things. So you can just start cancelling it out now. X plus 3, and this is another x plus 3. So numerator gets cancelled with the denominator, and then you have an x plus 2 in the numerator, x plus 2 in the denominator. So what are we left with? I can just multiply the two numbers. 5 times 2, 10. And here I have 4 times 3, 12. In the numerator, what else is left? X. And I have x square left in the denominator here. I need to simplify further now. Okay, so 10 divided by 12, you can simplify this ratio. 5 goes into 10 two times, and 2 times 10 is 5. So you can write as 2 is a GCF, 2 times 5 is 10, and 2 times 6 is 12. And then you have x divided by x square. I can cancel these two out, and I get my 5 by 6 using the exponent rule. X to the power 1 minus 2 becomes x to the power -1, and I have a 6 left in the denominator also. So my answer becomes